Here we've got a question 2 and 2.1 says, given the arithmetic series, so we've got 5 plus 7 plus 9, and it goes all the way up until 93. So a very basic arithmetic series. All we're doing is we're adding 2 each time. The good thing here is that we know what the last term is, just in case we need to calculate a sum. 2.1.1 says, determine the general term of the series Tn in the form Tn is equal to Pn plus Q. Now here's the thing. Pn plus Q may throw you off. But if you think about it, even though your Tn formula is going to be A plus D into n minus 1, once you simplify that, you will have the form Pn plus Q. So all we got to do here is work as we normally would. Okay, so we would normally say Tn is equal to A plus D into n minus 1. A here is the first term, which is 5. The difference is 2 into n minus 1. We're going to take that 2 and distribute it into the bracket, so we get 2n minus 2. And since they asked you for the format Pn plus Q, Pn is going to be this 2n, and plus Q represents the constant, so 5 minus 2 is going to be 3. That is our Tn formula. 2.1.2 says, the given series represents the number of kilometers that an athlete ran each week in preparation for an ultra marathon. So all of these values are kilometers, meaning that in the first week, he ran 5 kilometers. In the second week, he ran 7 kilometers. In the third week, he ran 9 kilometers. So they say the athlete ran 93 kilometers in the last week of the training program. How long in weeks was the training program? Basically, we want to figure out what is n here. What term number is 93? Because n is representing number of weeks, where T1, 1 represents the first week. T2, 2 represents the second week. In the second week, he ran 7 kilometers. T3 means in the third week, he ran 9 kilometers. So Tn, what is n here? Because whatever n is, that is the last week. So it could be 10, for example. We're not sure. That would mean that the last week was the 10th week where he ran 93 kilometers. But the best way to do this is to calculate it. So we know for questions like this, all we have to do is equate our general term to that value, which is 93. So I've got 2n plus 3 equals 93. I'm going to take the 3 over to the right. It will subtract. I'm left with 90. Divide throughout by 2. N is 45. So it means that this program was 45 weeks long. So this is T45. Okay, we've got another long story with 2.1.3. They say the athlete used this opportunity to raise funds for her high school. The community sponsored her 10 rand for each kilometer run during the training program. Calculate the total amount that the athlete raised for her school. So, here is the extremely important bit of information. 10 rand for each kilometer. Now understand that these values represent kilometers. 5 kilometers, 7 kilometers, 9 kilometers. And for every kilometer that she runs, they had sponsored 10 rand. Meaning that if we had to rewrite this pattern in terms of the sponsors that she got, in the first week, she would have got 50 rand. In the second week, 70 rand. In the third week, 90 rand. And it could continue like that up until the last week, where she would have 930 rand in that week. All we're doing here is multiplying by 10, because it's 10 rand per kilometer. Now the question itself says calculate the total amount that the athlete raised for her school. So we are trying to add the amounts that she raised over these 45 weeks. Since we are adding, we're trying to get a sum. We know that this is a series question. It is also arithmetic, so we are using the arithmetic sum formula. So here is that series written in terms of the sponsorships, and we are required to get the sum. So since we know what the last value is, we can use the formula Sn, okay, this is 2.1.3, Sn is equal to n over 2 into A plus L, seeing that we have the last value. So it's going to be S45 because it is over 45 weeks. We're going to add 45 terms. A is the first term, which is 50. The last term is 930. And the total amount of money that she had raised over those 45 weeks would be 22,050 rand. Let's now have a look at 2.2. It says the general term of a geometric sequence is Tn is equal to 2 to the power n plus 2. 2.1.1 says write down A, the first term. Now this is quite basic since we've got the general term given. All we have to do is substitute 1. So I'm just going to do it in here. It's going to be 2 to the power 1 plus 2, which is basically 2 cubed, and 2 cubed is 8. So term 1 is 8. Next, we need to calculate the common ratio. Common ratio is the base here, so R is 2. Now, 2.2.2 says calculate T20 and write your answer as a power of 4. So that is the general term that we're working with, and we are required to get T20. So all we're going to do is substitute 20 in place of n. This is going to simplify to 2 to the power 22. However, they asked you to write your answer as a power of 4, meaning that we need the base to be 4 instead of 2. Now, a way that we can do this is if we split up the exponent. So I'm going to split it up as 2 to the power 2 times 11. And the reason why we're allowed to do this is due to a specific law of exponents, which says that if we are raising a power to a further power, we multiply the two together. So if I take 2 times 11, I get 22. All I've done is I've broken down that exponent of 22 as 2 times 11 so that I can achieve this base of 4. So T20 is the same thing as 4 to the power of 11. And we are not going to get a value for that because the question specifically said write your answer as a power of 4. Now for 2.2.3 they say calculate, and notice what they've done here. We've got a sum to infinity. It is starting off as the first term, and our general term is now 1 over Tn. So the good thing is that we already have the general term, which is given to us as 2 to the power n plus 2. So I am just going to replace the Tn in the denominator with what it actually is, which is 2 to the power n plus 2. So here's what we're working with. And we are asked to calculate this, so you guys know that when it comes to a sigma notation question, your first step is to get the first 3 terms from the starting term. Our starting term is 1, so we are getting term 1, term 2, and term 3. So to get our first term, we are going to substitute 1 in place of n. For the second term, substitute 2 in place of n. And for the third term, 3 in place of n. Now, term 1 is 1 over 8. Term 2 is 1 over 16. And term 3 is going to be 1 over 32. This will allow you to get A, R. A here is 1 over 8. It's the first term that you calculated. To get r, we can take term 2 over term 1, and this is going to give me a half. Now, there's no need to calculate n because we are working with a sum to infinity. So the next step is to write out the formula, which is a over 1 minus r. Substitute what we have. And when you put that on your calculator, your sum to infinity is going to be 1 over 4. And now we've got the last question that says, consider the first 21 terms of the sequence. So the same sequence we've been working with, right? Tn is 2 to the power n plus 2. Calculate the sum of the terms in the sequence that are not powers of 4. Now, we need to write down a few terms so we can actually see which ones are powers of 4. Then we can figure out a way to work from there. So to start off, I would like to calculate the first 6 terms of this pattern. And remember, our formula is Tn is equal to 2 to the power n plus 2. So we've already got the first 3, which was 8, 16, 32. So we see the way that this is going, right? So continuing this pattern, the next 3 terms would be 64, 128, and 256. Now what I want to do here is first identify which terms from this pattern are powers of 4. So powers of 4 would be 16, which is 4 squared, 64, 4 cubed, and 256, 4 to the power 4. So what we notice is that it's term 2, term 4, term 6. Those are all powers of 4, which shows us that it's actually all of the even numbers, or even terms we can say, right? So term 2, term 4, term 6. The even terms are powers of 4. And I actually just want to make a note of that, so we've got it here. All even terms are powers of 4. And if we go back to the question, they had specifically asked you to consider the first 21 terms. Now, how does that help us here? If we are considering the first 21 terms and all of the even numbers, all of the even terms are powers of 4. Out of 21 terms, you can even count this on your fingers if you need to, but 10 of those terms are going to be powers of 4. So let's write this better. Let's say out of 21 terms, 10 terms are powers of 4. That's going to be term 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We're not going to say 22 because it stops at term 21, okay? So there's only 10 terms that are powers of 4. Now they had asked you to get the sum of the terms that are not divisible by 4. When you have this kind of question, the not divisible by kind of question, there are 3 steps that we take. The first step is to calculate the sum of all terms. And when I say all terms, I mean all of the terms as you see it. The 8, 16, 32, 64, everything. Okay? All of them. Now, if I calculate the sum of all of these, I know that this was a geometric series. I know that R is 2 because it's a question that we did answer. I think it was A, actually it was B. Substituting in here, all the terms are going to be 21 terms because they said that we are considering the first 21 terms. So we're going to get S21. A here is 8, R is 2. So 2 to the power 21 minus 1 over 2 minus 1. And if I just plug this onto my calculator, this is the value. The next step is I'm going to calculate the sum of the terms that are not divisible, but they said powers of 4, so that are powers of 4. So terms that are powers of 4, if we just go back up, it was 16, 64, 256. Okay, it's these terms. And what do we notice here? These terms, how many of these terms are there? If 10 of those terms were powers of 4, which we had made a note of, okay? So we are actually working with 10 terms here. And here A would be 16, R would be 4. We're actually multiplying by 4 each time. Remember, they are powers of 4. So this is going to be our geometric series formula. We are getting S10. Here A is 16. R is 4 to the power 10 minus 1 over 4 minus 1. And this is going to give you 5592400. So this is the sum of all the terms that are divisible by 4. However, what did the question actually ask you for? They wanted the sum of the terms that are not powers of 4. Okay, so to do this, we had 21 terms in total. Those were all the terms. 10 of those terms are divisible by 4, meaning that the number of terms that are not divisible by 4 are going to be 11. So we are going to take the sum of all the terms, which is this value. We are going to minus the sum of the terms that are divisible by 4, which is the value above, 5592400. And the remaining value gives us the sum of the terms that are not divisible by 4. So whenever we have this kind of question, and it's actually a very common question in grade 12 papers. If you have been working through past paper questions, you would have already come across this. They often like to ask for the sum of values that are not divisible by something. So we have these 3 steps. We get the sum of all the terms, the sum of the terms that are divisible by that particular value, and we subtract the 2. So it's a very logical approach, and it is an easy enough method to remember to ensure that you get those 4 marks. Okay, so we are done.